Diffusion. Take a glass of water and with the help of a dropper, put a drop of ink in the water. Here you can see that the drop of ink is separately visible from the water. In other words, the interface between the ink and the water is distinct. But after a while, you can note that the ink has completely dissolved in the water. How does this happen? Water as well as ink consist of constituent molecules which are randomly in motion. But the concentration of the ink drop is more than that of water. Hence, the molecule of ink start moving towards the molecules of water. In other words, the molecules of ink spread out into the water. This spreading out takes place from an area of high concentration to an area of low concentration. This process is called diffusion and is defined as the movement of molecules from a highly concentrated region to a less concentrated region. Simultaneously, because of its constant motion, few molecules of water also move towards the molecules of ink. But this number is considerably less. Hence, the interface between ink and water becomes less distinct. With time, both the molecules of ink and water intermingle with each other and the mixture becomes homogeneous. Thus, the ink is diffused in water. Diffusion is observed not only in liquids, but also in gases in which it occurs very easily. Whereas in solids, diffusion hardly occurs. For example, when a block of lead is kept in contact with a block of gold. After several years also, hardly any diffusion can be noticed. This is because the atoms of solid are tightly packed together. Because of this tight packing, the particles are not capable of diffusing very rapidly as the rate of diffusion is very low. When we spray some perfume, even in one corner of the room, immediately its fragrance spreads throughout the room. This is an example of diffusion occurring in gases. Consider a setup in which few drops of liquid bromine are placed in the bottom of a test tube. The liquid bromine immediately evaporates into a reddish-brown gas. These reddish-brown gas molecules immediately start spreading out into the entire test tube. After a little while, the molecules of the bromine gas diffuse up the test tube. The entire test tube is filled with bromine gas. Similarly, when a perfume is sprayed in a room, its constituent molecules immediately diffuse into the air present in the room, and thus the fragrance can be smelled everywhere. Consider another experimental setup where a cylindrical porous pot is taken to which a U-shaped glass tube is attached. This tube is filled with some liquid. Cover this porous pot with a beaker to which hydrogen gas can be supplied. When hydrogen gas enters a beaker, the level of liquid in the closed end decreases. Simultaneously, the level of liquid in the open end rises. This happens because hydrogen has lower density than the surrounding air. Hence, its molecules are faster than the air molecules. So the speed of diffusion of the hydrogen molecules into the porous spot is faster than the speed of diffusion of the air molecules out of the porous spot. This creates an excess of pressure inside the porous spot, due to which the level in the closed end of the glass tube decreases, whereas that of the open end rises. Now, change the setup so as to replace the hydrogen supply with carbon dioxide. This time the level of liquid in the closed end increases, while the level of liquid in the open end decreases. Here, the carbon dioxide molecules are denser. Hence, they push the air molecules upwards and sink to the bottom of the container. Simultaneously, the air molecules inside the porous spot move out due to their inherent motion. But the speed of their diffusion out of the pot is faster than the speed of the carbon dioxide molecules entering into the pot. Hence, the pressure inside the porous spot decreases, due to which the level in the closed end of the glass tube rises, whereas that of the open end decreases. So from these experiments we can conclude that the density of the diffusing gas inversely affects the speed of diffusion. Next, let us see the other factors on which diffusion depends. If the temperature of the liquid or gas is increased, the speed of diffusion also increases considerably. This is because an increase in temperature increases the kinetic energy of the molecules, due to which the rate of diffusion increases. Similarly, if the difference in the concentration between the two diffusing agents is more, it helps in increasing the speed of diffusion. Hence, the factors affecting diffusion are density of the diffusing agents, their temperatures, and the difference in their concentrations. Diffusion is observed in various processes occurring in our body. The process by which the respiratory gases like oxygen and carbon dioxide are exchanged with the cells is a good example of diffusion. Similarly, nutrients from the blood diffuse out of the vessels to reach the tissues.